Hello everyone, this is Professor Robert Solis. Welcome to our next video lesson. What you're going to do is you're going to create a program that will randomly display two integers and randomly display an operator. The user is supposed to place the answer here in this text box and then click the submit button. So for example, let me zoom in a little bit so I can show you what happens. This is the initial view of the program. Let's say that the user enters the number 1 and then clicks the submit button. Well, since 3 minus 2 is equal to 1, they click submit and then the word correct appears in this label down here. Notice that the background color is green. Alright, but what if, say for example, for that same problem, 3 minus 2, let's say that the user enters 8. Well, obviously that's not correct, so when the user clicks the submit button, notice that the word wrong appears in the label and the background is red. At this point, the user can click the next problem, and then what it'll do is it'll display a brand new problem with new integers and a new operator, perhaps randomly selected. So once again, the user is going to enter in what they think the answer is and click submit. But what if the user doesn't enter anything? What if they leave this blank? What if they enter a letter, or maybe they enter a symbol like dollar symbol, ampersand, pound symbol? What if they enter something like that and then click the submit button? Well, then we want a message box to appear indicating that there's an invalid input, that they have to enter a number. And then they would go ahead and click OK, and then it would return them back to the problem so that they could attempt this problem once again. Alright, so that's the premise behind this particular lab. There are some user requirements in terms of what needs to be displayed if the user gets the problem right or wrong. There's also some software requirements. As you can see here, we're going to use a random number generator to determine the operator, whether it's going to be addition or subtraction. We're going to use a random number generator to display two numbers between 0 and 9. So over here, this will be the first number, this will be the second number. So in essence, we'll call this operand 1, operand 2. We're going to use a try block to determine if the user's entry is valid. So if they don't enter a valid number, then we need to make sure that we display a message box. So over here it says if it's valid, determine if the answer is correct or incorrect. If it's invalid, then we display a message box. And then of course we have to create appropriate names for each of the various controls in the form. Okay, so that's what we need to do. Alright, so let me switch over to Visual Studio 2008, and I created a project called VB Lab 15 project. It's a Visual Basic project, obviously. And I've already created the form, so let me give you the sizes and the names of the different items on the form so that you can go ahead and create your graphical user interface as well. Alright, well the first thing I did was obviously I created the form, and the text property, as you can see here, for the form is supposed to be arithmetic problems, right? Because again, I'm just looking at the handout and trying to mimic, to draw exactly what this graphical user interface looks like. So make sure that you change for the form, you change the text property to arithmetic problems, and you'll also want to make sure that the maximize box and the minimize box are set to false so that you don't see those on the form. Alright, next you're going to display a couple of labels, or several labels. In this case I have LVL Op1 is the name of this label, and I'm going to just right off the bat set it equal to 1 in terms of the text property, right? It's going to be randomly generated, as I'll show you in just a moment when I develop the code, but just to get this graphically on the form, I'll set the text property equal to 1, and the name of this label is LVL Op1 for operand 1. This will be LVL Op2 for operand 2, and also I set the text property to 1, as you can see here. So the text property set equal to 1. For this, that's going to be LVL Operator. So in this particular lab, I had indicated that I wanted you to make it either an addition or a subtraction type of operator. So I'll start off with this as addition. So the text property is plus, the plus symbol, and the name property is LVL Operator. And then this, that's nothing, right? It's just, I don't name it, I shouldn't say it's nothing. It's just simply a label with the equal symbol. And then I have a text box over here. Now the text box I've called txt user input. I'm going to obtain the user's input, and then I'll have to convert it to a number. I also have a button here, btn submit, with the text property of submit. I have this button over here that says btn next problem, and of course the text property is next problem. And one thing you don't see is this label right here. All right, so let me select it here. I created a label called LVL message, and what I want to do is I want to change the message to the text alignment to middle center, so that when there is text, and so let me type a couple letters here. When there is text inside of it, as you can see, it's going to appear in the middle and centered. Now obviously this is a much larger font, so what I'm going to do is I'm going to show you what font I selected. Looks like I selected Arial and 36 points. Okay, so this is Arial 36 point. In fact, I think it's the same thing for this label. Yep, this is also Arial 36, Arial 36. All of these are Arial 36. And in fact, even for the text box, I changed that as well. I don't think I changed the font, but I definitely changed the font size to 36. All right, so let me get rid of this text property for this bottom label, and like that. Now the reason why this is blank and the reason why it doesn't have a border, let me go back to the handout. You'll notice that it appears in the initial view to be invisible, but of course when I click the submit button, that's when it's going to display with the appropriate wording and also the appropriate color, depending on whether or not the user got it right or wrong. Okay, so let me see here. What's the form size? In my particular case, my form size is approximately, well, it's not approximate, it's exactly the 456 is the width in points, and then the height is 240. Again, your form doesn't have to look exactly the same size as mine, but if you want to get it to look approximately like mine, these are some of the values that I have. Okay, so that's the graphical user interface. Let's go ahead and start programming. So the first thing that I'm going to do is I'm going to double click the submit button, so it takes me into the code area. And I'm going to minimize the properties panel. All right. Now, before I start to generate the code for this problem, I want to talk to you about what we're going to do when we initially run the program. So, for example, let me go ahead and start debugging by clicking this button and start the problem, or start the program. When this appears, there is a special event called form load that allows certain things to happen before this form is displayed. So as you can see, it's displaying the form. Oh, by the way, notice that the next problem button is disabled and the submit button is enabled when you initially run the program. Now, we want these things to happen automatically before the form is loaded. I want this to be disabled, I want this to be enabled, I want this to be enabled if I click on it, obviously, and I want these numbers to be randomly changed, and I want this operator to randomly change before I load this form. But first, let me talk about enabling and disabling this button. That's an easy part. All I'm simply going to do here is I'll select this button, and in properties, specifically for the enabled property, I set it equal to false. This one, I'll set it equal to true for the enabled property, right? So enabled property, I set that equal to true. That way, when this one's enabled, this one's disabled. When this one is disabled, this one will be enabled. Maybe I said that wrong. Let me try that again. When this one is enabled, this one is disabled. When this one is enabled, this one will be disabled. So only one of these will be enabled at any given time. Okay. Okay. Now let me go back to what I had mentioned before, which is I only want. Sure. Let me restate that. I want these operators. Let me restate that once again. I want the operator to be either plus or minus, and I want the operands to be randomly generated before the form displays. In order to do that, here's what you'll need to do. First, I'm going to click this drop-down arrow where it says class name. This is the class name drop-down arrow. And so I'm going to select Form 1 Events. Do the same thing, Form 1 Events. The Form 1 is the name of the form, right? So this is the form that over here, as you can see, Form 1. I haven't changed the name, so I'll just leave it at Form 1 Events. Now, what particular event are we interested in for the form? If you'll scroll down a little bit, you'll see that there is a load event. So go ahead and click that. When you do that, a new procedure will open up called Form1_load. What this procedure does is this is the first procedure to run when you first open the program. So any code that I'm about to type in here, that will be executed first before the BTN submit button is clicked, before the BTN next problem button is clicked, before anything happens. The stuff inside of here will first run. And that's the purpose of the load, the Form 1 load event. Okay. All right, so the next question then is, what is it that we want to happen when the program first opens before it even displays? Well, the first thing that I'm going to do is I'm going to create a couple of random numbers, right? But before I do that, let me create some modular level variables so that all of the different procedures can see these modular level variables. So I'll declare modular variables. Well, the first one that I'm going to declare is called mint op1 as integer. All right. Now, that looks funny, mint. What do I mean by that? Well, what I'm trying to do is this. First, the m represents that this is a modular level variable. It is an integer, and op1 is really the name of the variable. So what I'm doing is I'm showing you an older way that people, Visual Basic programmers, used to declare modular variables. They would put this letter in front of it. If it was a modular variable, they'd put an m in front of it. If it wasn't, then it would be empty like this. Or you wouldn't put the m there. All right, let me put the m back in here. Some people don't do this. Some people don't put int. They just would do something like this. This is a modular level variable, and it is called operand 1. And the reason why they wouldn't put int there is because if you hover your mouse pointer on top of the variable, you could see here that it is an integer, right? Here's the problem. If you're looking at a hard code, or if you're looking at a printout of this particular program, you won't have the opportunity, obviously, to move your mouse pointer on top of the variable. So creating it like this gives you an opportunity to see that this is a modular level variable and that it is an integer. Now, do you have to do it this way? No, not at all. It just depends on the company that you're working for and what their requirements are. What I'm showing you here is an older way of doing it so that when you see this code out in the industry, you'll understand what it looks like, or what it is that is trying to be communicated here. Namely, this is a modular level variable. It is an integer, and we're going to call this op1. So the whole variable name is mint op1. It's going to be the first variable. All right. Similarly, we'll create mint op2, or so modular integer op2 as integer. We're also going to display or create a variable called mint result as integer. Mint user input as integer. Let's see here. String operator as string. And finally, actually before I do this, let me explain what I've just done here. All right, I need a variable that will either be equal to the plus symbol or to the minus symbol. We're going to randomly select from one of those two. So what I'll do is I'll create a variable called operator. Now this operator variable is going to be modular in scope, and it's going to be a string in terms of its type. So mstring basically says this is a modular level variable, it is a string, and the name of it is operator. So mstring operator is the name of this variable, and we're treating it as a string. And then finally, the last variable that I'm going to create is called mRandomNumber, or mrand, and as new random parentheses system.date, system.datetime .now.millisecond, close parentheses. All right, let me describe this variable. First of all, it is modular in terms of its scope. And I want this to be a random number. Why do I want this random number generated? Well, I want this to be any number between 0 and 9. And same thing over here, 0 and 9. And I want this either to be the plus symbol or the minus symbol, right? Well, how am I going to do that? The way to do that is to create a random number generator, and that's what this variable is going to be. It's going to be equal to some random number. Well, to do that, then what I'm going to do is I'm going to say take this and instantiate it as a new object. So this really isn't a variable like these guys, right? These are variables. They're integers, doubles, strings. We consider those to be variables. But this is going to be an object, and it's going to be an integer object. It's going to equal to some number, all right? And what that number is going to be equal to is going to be based on the random number class, as you can see here. Now, when you have the random number class, it's going to ask, well, what is the seed value? What is it that makes this thing random? That's the stuff inside of the parentheses. See, I could have done this, and what would have happened is mrand would have been equal to a random number that is generated by the random class. All right, well, here's the bad thing. Randomness from a finite machine, well, that really can't be done. So what we're trying to do is we're trying to seed the value, give it some sort of a random initial value. How are we going to do that? Well, that's what this whole thing is about. Notice that if you were to go to your clock, right? So here's my clock over here. Let me open that up. And right now my clock says it is 10:26:41, and there's also milliseconds that are associated with this clock as well, right? You don't see the milliseconds, it's not being displayed, but inside, internally on my machine, there are milliseconds. Well, what I'm going to do is by typing system.datetime.now, which is the time right now on my machine, .millisecond, what this does is it says, given this initial seed value, generate a new random number and assign that, or place that rather, into mrandom. So let me say that again. We're going to generate a new millisecond seed value. We're going to place that as a new random number into mrand, into the mrand object. So now what I'm saying to you is that this is a way to generate a random number. So currently this thing is equal to some random number. It's probably going to be a random number between 0 and less than 1. All right? So that's how you generate a new random number, by just simply typing this statement here. Okay, so now that I have all of my modular level variables, let's go ahead and go back to the form1load function or procedure. And this is what I need to do. I need to obtain 2 new random numbers. All right, so I've already created the variables for those, mint1 and also mint op2. So mint op1 is going to equal to, okay, let me take that random number variable that I created, right? So here you can see here, it's a random number, and what I want to do is put the dot operator there and then click on next. Let's describe what next does. As you can see here, it returns a non-negative random number, and that's what I want this thing to do. Give me a random number. That's what this thing is going to do. So if I double click on next, it'll give me a non-negative number and it'll put it into here. But I don't want just any non-negative number. If you'll notice from the handout, there are certain requirements that I've given to you, namely that you're supposed to use the random number generator to display 2 numbers, either between 0 and 9. So I shouldn't say either between, let me say that again. You're going to use a random number generator to display 2 numbers between 0 and 9. Well, currently, this is going to return any number. I don't want to do that. I want to return a specific number between 0 and 9. How do I do that? How do I make that constraint? So I'll type parentheses. Well, the first thing that I'm going to do is I'm going to indicate what is the lower bound of the number. Well, I want any number from 0 to 9. So notice over here, when I type 0, it says that this is the minimum value, and notice what it says, the inclusive lower bound of the random number is returned. What this word inclusive means is including the number 0 is the least value that will be returned. Let me press a comma now, and notice this says the exclusive upper bound. So whatever number I type here, that will be excluded, but anything less than that number will be included. Hence the difference between the word inclusive and exclusive. So if I type in 10, for example, what I'm saying here is this. return a number that is equal to 0 and less than 10. It can be greater than or equal to 0, and it must be less than 10. So make sure you understand the difference. If I did this, if I put a 9 here, and let me close those parentheses. If I put a 9 here, that means that this function, or this random number variable, is going to return either 0, 1, 2, 3, 4, 5, 6, 7, 8. It will not include 9 as part of the random numbers that are going to be returned. Why? Because this is an exclusive item right here. So if I type in the number 10, that means that all numbers from 0 all the way up to 9 will be returned. Okay? So that's how I'm able to generate a new random number. Now I have mint op2. I want to do the same thing here. I'll say mrandom.next 0 to 10. And then close the parentheses. So that is how I'm going to generate two new random numbers. Well, now that I have those two new random numbers, let's go ahead and assign them. So I'll say assign the random numbers to the labels. And the way that I'm going to do that is I'm going to say LVL op1 dot text property. All right, so I'll need to convert these because they are numbers and not strings, so I'll have to convert them to strings. And so I'll say int mint op1, and then for the second label, I'll convert those to a string, and mint op2, this one right here. All right, so here's what's going to happen. When the program initially loads, we are going to generate two brand new numbers between 0 and less than 10. And then after we've done that, we're going to display them in these two labels. So what happens at this point is that this label and this label gets assigned the new random numbers that were created over here. Okay? So now that we have this, I have to also generate a random operator. So it either has to be plus or minus. So this is going to be the randomly select either addition or subtraction, then assign it to the operator label. Okay, so that's this section of the code. Well, how do we determine how do we randomly generate either a plus or a minus? Well, we really don't. But what we're going to do is we're going to use the mRandom object as a way of generating a number that's either going to be something that is less than 0.5 or greater than 0.5. And here's how it works out. First of all, let me type in mrand dot. You're already familiar with what next does. Now let me introduce next double. So notice what this thing does. It's going to return a random number between 0 and 1. So in other words, 0.0, 0.1, 0.2, 0.3, so forth and so on, all of those numbers up to 0.99999999999, but not including 1, right? So any number in between there is going to be returned. So next double. Now you know what that does. It's going to return a number between 0.0 and less than 1. So what I'm going to do is this. I'm going to say if this number is greater than or equal to 0.5, then if that's true, then my string operator is going to be the plus or the addition symbol. Else, if that's not the case, then the mstring operator is going to be equal to the subtraction symbol. Simple as that. All right, so let me make sure that you understand this. I'm going to take this object. I'm going to use the dot next double function. And what this thing is going to do is it's going to return a number anywhere from 0.0 to 0.9999999, any number in between. If that number is greater than or equal to 0.5, then the operator is going to be equal to plus. If it's not greater than 5, then we'll make it equal to minus, or assign it to minus. So this is a way of basically determining of whether it's going to be an addition or subtraction in terms of the symbol, right? But once I have that, now I can go ahead and place that in the label called operator, and the dot text property is going to equal to string operator. So now when I first run the program, see, remember, we're still on the Form 1 load procedure, which means this is the first thing to happen before it even displays the form when you run the program. But what's going to happen is it's going to take this operator, which, as you'll recall, is called LVL Operator. It's going to take that and either assign it to either addition or the subtraction symbol. How do we do that? Well, I randomly generate a number. If I randomly generate a number that is greater than or equal to 0.5, then we're going to make this thing plus. If it's less than 0.5, then we're going to make this thing minus. And then, of course, I send it out to the label. All right? Well, the last thing to do then, in terms of the form load procedure, is to enable and disable the buttons appropriately. So what I mean by that is this: btn submit. The btn submit button is supposed to be enabled when we first run the program, so we'll set that equal to true. Now the btn next problem button is not supposed to be enabled, so we'll set that to false. So this button, make that enabled, but this button will disable it when we first run the program. Okay, so this is all going to happen when I first run the program. Well, let's try it out. Go ahead and start debugging. Watch what's going to happen. So 8 plus 9 is the first, is randomly generated, I should say. 8 plus 9 is randomly generated. The random number 8, the random number 9, the random number plus. Let me close this application and try it again. So I'm going to start debugging. All right, this time it came up with 8 plus 2. All right, let me close this application, try it again. So 7 minus 3 came up. So as you can see, the form load procedure is the first thing to be executed. And what are we going to do? All this stuff that I've just typed. All right? So now you have the form that automatically generates the two operands and also a random operator. Well, now that we've done that, let's focus on the submit button. And what's going to happen with the submit button is, whatever the user's input is, we need to verify that the arithmetic operation is, first of all, we need to verify what the arithmetic operation is equal to. So for this, in this example, if it's really 1 plus 1, that's going to be 2. We need to determine if the user's entry is 2. If it is 2, we display correct. If it isn't, then we display wrong. All right, so let's double click the submit button. And here's the code here for the submit button. Now what we're going to do is we're going to use a try block to obtain the user's input. So let me put a comment over here that says obtain the user input. All right, we're going to use a try block. So I type try, press enter. So remember, the try block says, let's try to do this. What are we going to try to do? Well, we're going to try to assign something to this variable called mint user input. What I'm going to do is I'm going to convert to int32 whatever is inside of the text box. Okay, so take the text from this text box, convert it to an integer, and then assign it to this variable. That's what I'm going to try to do. Now, if it works, great, no problem. It's not necessary to go to the catch area, because we're going to try to do this. But what if the user did something like this? What if the user put the letter Q here or left it blank? Well, you can't convert a blank or a Q or some special symbol to an integer. You can't do that, and you certainly can't assign that to an integer variable. So if it didn't work out, that's where the catch section comes in. Well, what do we want to do if the user didn't enter the right value? So we'll display a message box. And in this message box, we're going to dot show it, parentheses. All right, what are we going to type? Well, first of all, I'm going to type, the title is going to say enter a number. Actually, the text rather is going to say enter a number. All right, and let me go back over here to the handout just to remind you of what this is supposed to look like. The message is supposed to say enter a number, invalid input, and then we have an OK button. And then we also have that there was some sort of an error, as you can see here by that X. All right, so we're going to say enter a number, comma. And what is the title? Invalid input. As you can see here, they're calling it a caption, right? So it's the caption or the title for this particular message box. All right, so let me close this, quotation mark, comma. What type of message box button am I going to display? Well, I just simply want the OK button to display. So I'll double click on OK. And then comma, and then we're being asked what type of message box icon do I want to display? And that red X is this guy right here, error. So message box icon, I'll double click on this so it's an error. Let me close the parentheses and then I'll press enter. So this message box is going to appear telling the user, hey, you've entered something incorrect. Well, after we've done that, let's say that, let's go back to the handout. Let's say that the user has this displayed. They click OK, right? Well, whatever they entered into here, if they left it blank, then that's no big deal. But what if they put the letter Q in the text box or an ampersand or a dollar symbol? What if they did that? Well, we want to get rid of it. We want to blank it out. So after they click OK, let's get rid of the contents of the text box. And so the way that we're going to do that is as follows. We're going to type txt user input dot text, and we're going to assign that to nothing, quote, quote. So what this thing does is it says blank out the text property for this particular text box. Okay? So now that it has been blanked, the next and the last thing that we want to do here for this try block is we want to end the sub or exit the sub. Here's what's going to happen. We have some additional code to type in just a moment here. I'm going to type some more code. This is the way a try block works out. It's going to try to do this. If it worked, then it's going to do the rest of the code that we're about to type after the end try. If it didn't work, the catch portion is going to execute, which is going to do these statements right here. Now, if I didn't have this exit sub, what it would do is it would execute this, then it would execute this statement, and then it would go to the next statement after the end try. It would execute anything that's blinking or that's currently entered right here where the cursor is blinking. Well, that's not what I want to do. What I want to do is I want to display the message box. I want to clear out the user's input in the text box, and then I want to exit this entire subroutine or this entire procedure. I don't want it to continue operating. So that's why I place an exit sub right here. If there was a problem, display the message box, clear out the text box, and exit out of this procedure, which in this case it says exit sub, right? So we're going to exit out of this guy right here because it's no longer valid to keep on going on. What if the user was successful in taking the number, say for example, and putting it into this variable? Well, if that really did happen and if everything's okay, so then we want to do this next part. First, I want to determine the correct arithmetic result. Well, how are we going to do that? Well, the first thing I have to do is I have to determine, hey, is this thing plus or minus? Right? Are we adding things or are we subtracting numbers? So what I'm going to do is I'm going to find out if mstring operator is equal to plus. Right? If it's the plus symbol, then the mint result is going to equal to mint1 operand 1, I should say, and mint operand 2. We're going to add those two together. So if the symbol is plus, right, if this string operator is plus, then that means add these two and place it into the mint result operator, or that's right, a mint result variable, I should say. If that's not the case, then mint result is going to equal to mint op1 minus mint op2. So what I've done here in this section of code is I'm trying to find out, hey, for whatever the random number is that's being displayed for this and for this, do I need to add them or do I need to subtract them? Well, that's based on the operator. That's based on this guy right here. Is it addition or is it subtraction? So if it is the plus symbol, add the two numbers. Otherwise, if it's not this, then we'll assume that it's got to be the minus symbol. And so therefore, let's subtract these two and then place the result into mint result. Well, once I have that, now I can determine if the user got the answer correct, right? So did the user get it right? How do I determine that? Well, what I'm going to do is I'm going to take the users, so mint user's input, and I'm going to compare that with int result. So I've just determined what the result is based on the two numbers that are being displayed. That's this right here. I'm now going to compare that with the user's input to find out if both of these are equal. If they are equal, then the user got it right. If they are not equal, then the user obviously did not answer the question correctly. So first of all, let's assume that they got it right. If that's the case, then the message, the LVL message label, specific to the text property, should be assigned the word correct. And we also have to make sure to take the back color for that label, and we're going to set that equal to color.green. Okay, let me go over this section of code. Did the user get it right? Is the mint result and the mint user input, are they both the same value? If they are the same value, then the text property for the label message is going to display correct. We're talking about this guy over here, this label. That label will now display the word correct, and its back color will be a solid green color, which, as you'll see from the handout, that's exactly what we want to generate, the word correct and a green background. Okay, so the back color will be that. Now what if the user got it wrong? So in the else portion, we'll say this, LVL message dot text will be equal to the string wrong, and LVL message back color will be equal to the color red. So let me scroll down here to red, this guy right here. So what this if statement does is it determines if the user got the answer right or wrong and displays the appropriate text and the appropriate back color, whether it's green or red. Well, once I've done that, then I want to say LVL message dot visible, because currently when we first start the program, it is not visible. Let me go back to the handout. You'll see that the message is not visible. Once we've determined if the user has answered the question correctly or incorrectly, we can now display it. So what I do is I change the visible attribute of this label to true. So now we can see it. Once we've done that, we also have to swap the button's enabled property. So for example, for BTN submit, for this guy, the enabled property is going to be false. And for BTN next problem, the enabled property is going to be equal to true. So in other words, what I'm saying is this. Once the user clicks the submit button, let's disable this button, and we're going to enable this button. That's what's happening here. We're going to disable the submit button by setting it equal to false. We're going to enable the next problem button by setting its enabled property equal to true. All right, let's see what happens. Let's run the program. We're not finished yet, but we're just going to check it out, see what happens. All right, so 7 plus 1. Well, first, let me not enter anything and click submit. Let's see what happens. Perfect. Invalid input, a message box appears. Great, so let me click OK. And what I'm going to do now is I'm going to enter in a value of, let's see here, let's say ampersand. 7 plus 1 is equal to ampersand. Is that true? Well, first of all, that's an invalid input. I have to enter a number. Okay, good. So we blank it out. That's nice. Click back inside here, and let me type in the number 8, and then click submit. Now, as soon as I click submit, this thing should be disabled, and then this button should be enabled. Let's see what happens. Perfect. So the button is disabled, this button is enabled, and notice that since 7 plus 1 is equal to 8, that is correct. So therefore the word incorrect appears, and there's a green background. Now we haven't developed the code for the next problem button, so when I click it, nothing happens. Let me try it one more time to see what happens if I get the problem wrong. So let me close the application, let me start debugging one more time, and let me enter an incorrect answer. For example, 1. 3 plus 3 is equal to 1. Is that true? Let me click submit. That says wrong. 3 plus 3 is not equal to 1. So therefore wrong displays, the red background, looks good. All right, so now what we need to do is to develop the code for the next problem button. So let me double click it, and here we go. Now the next problem button, the first thing that we're going to need to do is we're going to need to clear and reset all the necessary screen objects. So let's do this. Let me create this comment. So clear and reset all the necessary screen objects. How do we do that? Well, first of all, the txt user input.text box is going to be equal to nothing, right? We're going to set that equal to quote, quote, so it's blanking it out. For the message, the text property specifically for the message, I'm also going to type in quote, quote, because we want to blank that. And in fact, we want it to be invisible. So for the visible property, we'll set that equal to false. So that's the first thing we want to do. Next, we want to generate two new random numbers. We want to assign those random numbers to the variable. We want to randomly create either an addition or subtraction operator, and then we want to enable and disable the buttons appropriately. Well, all of that code has already been created over here with Form 1. So all I really need to do is copy and paste this same thing. I need to generate two random numbers. I need to assign those numbers to the labels. I need to randomly select the plus or the minus symbol, and then I'm going to put this into the operator, and then I'm going to enable or disable the buttons, specifically the BTN submit and the BTN next problem button appropriately. So I'm just going to copy all this, right? And all of this code was already inside of the form mode, so I'll just hit Control C for copy and go back over here and then hit Control V as in Victor for paste. And so now all of this same code is going to be placed inside of the next problem click event or click procedure. Now this is kind of redundant. Well, it's not kind of, it is redundant. I have the exact same code running in two different parts of the program. That seems a little inefficient. Later on when we talk about functions, we'll redo this problem and we'll generate a new function that we can call, so that way I don't have to be copying and pasting entire blocks of code that are identical. So we can just refer to a function, but we'll talk about that later. For right now, I want you to understand that when I click the next problem button, when I click this button over here to generate a new problem, then this has to be a new number, this has to be a new number, and this has to be randomly selected, either addition or subtraction, when I click this button. And also, whatever the answer is over here from the previous problem, let's get rid of it, so we'll blank it out. If there's a message that's displayed, let's erase that, or not erase it, right? Let's make it invisible so that we don't see it. Well, how are we going to do that? We're going to clear and reset all the necessary screen objects. So what we're going to do is the text box, we're going to blank it out. The message, we're going to blank it out. And we're also going to make it invisible. Now, let's obtain two random new numbers. So this will generate the two new numbers. Let's now place them into the labels, op1 and op2. So that's what these two statements do. This is going to generate a new operator. Whether it's addition or subtraction will be based on the random number that's returned. So if this thing is greater than 0.5, then it's going to be plus. If it's less than 0.5, then it's going to be minus. Then the LVL operator is going to be equal to whatever the string is, either plus or minus. Then we'll take the submit button, we'll enable it, and we'll take the next button problem and we'll disable that button. All right, let's run the code. 9 minus 7. Let me answer this one correctly. So 2, submit, correct, great. Let's try the next problem. 0 plus 1. I'm going to enter 2. Submit, that's wrong. Next problem. 8 minus 1. 1. Submit, wrong. Next problem. 0 plus 4. 4. So as you can see, our program works. Let me try to get it to the point where I have to enter a negative number. Let's see here. Perfect. 0 minus 6. Well, that's negative 6. Click submit. That works out okay. So you'll notice that the numbers are anywhere from 0 and less than 10. You'll never see the number 10 here. So what's this one? It's going to be 5. This is going to be 0. Looks like our program works. So let me close this output window, and I think that's it. This is Professor Robert Solis. I hope this has been helpful. Have a good day, See you next time.